here are the rules for the exponents. X squared is clear, the meaning, and then the zeroth power we found has to be 1, and the negative power means to reciprocate. Therefore, negative second power means to put a square down below. And the fractional power means taking roots first, then raised to power n. So 2/3 means take the cube root, then raised to the second power. And then finally, negative fractional power means not only doing the roots and power, but you flip it downstairs also. And decimal power, therefore, is to be interpreted as fraction first over here. Therefore, we square root and cube, then we wind up with 27. 1.22 means it's going to be 61/50 as a fraction. So it's a 53 raised to 61 power. Of course, we need a computer for that. Now, how about real number? Then, for instance, what's meaning for 10 to the pi power? What we approximate, we take the decimal of pi, 3.1, then we interpret that as the 10 to the 31 to the 10th. Then we do approximately more and more detail. Then we wind up with the number that, as we call it in limit, but we define this number to be 10 to the pi. In this manner, we can define then what we mean by exponential functions with a different base over here, base 10, base e, or base 2. This shows up in compound interest. For instance, if I have $1,000, I get 1% interest for the month. So after 1 month, I'm going to get $1,010. But after 2 months, I multiply this number by another 1.01, and then accumulate more interest now up to 1020.10. Now, if after 3 months, I find that the patterns for finding how much return is I take the number and treat it as exponents. And so we get this Pina formula. Therefore, it says after n period, and with principal pi is the periodic interest rate, then this formula is, we call the Pina formula. It gives you the accumulation. For instance, this is visually, we start with P, then after 1 period, after 2 periods, so after n periods, I get that formula. So $1,000 after 160 years, how much do I get in returns? Well, change into those numbers, then plug the formula, I find the accumulation is that much. And this is the backward. If I want to accumulate 2 million, how much do I have to have principal? Then divide by it. And these are the graphs of the exponential functions. Okay, and that's it. Bye-bye.